So today's lesson is dealing with exponential relationships. Today's lesson is dealing with exponential relationships. In general, the relationship looks like this. Y is equal to AB to the exponent x, where A is the initial value. And you'll hear me often refer to this as the start value. The start value. And anything that is raised to the exponent x represents what we call the growth or decay rate of a relationship. So anything raised to the exponent of x. So just like I said, A is the point where the graph crosses the y-axis, otherwise known as the start value. We studied that earlier in the year when we were dealing with our review of grade 10. Now, when we take a look at the following graph, you'll notice that we have y is equal to 4 raised to the 2x. Now the number 4 that's not being attached to the exponent is what we call the initial value, the starting value of our parabola. Sorry, not parabola, our exponential. And what we're going to do is we look at the other part here. This other part represents what we call the growth factor. Now the reason why it's a growth is because this thing essentially is doubling each time. So the first time you have 4, the next time you're going to have 8, the next time you're going to have 16, the next time you're going to have 32, and so on and so forth. That's if we moved from left to right, but if we were moving from right to left, we would be, instead of multiplying by 2, dividing by 2. Now, I want you to take a look at this next one. So this next graph is y is equal to 2 bracket 1/3 to the x. Now, that 1/3 to the x is basically showing that its initial value, like we said before, the starting value, the A value of our equation, is 2. And anything that's associated with the exponent is going to be either the growth or decay rate. Now, the reason why this graph swoops down is because it starts big and goes small, because every time you move one step to the right, you're actually cutting off a third. Everything ends up being a third of the previous. So if I had 6 and I moved over to the right one, for my next value I would get 2. And then for the next value, if I moved to the right, would be 2/3, and so on and so forth. So essentially this thing will shrink. So now we're going to go and take a look at some information. Now, the B tells us whether the graph will increase or decrease. If I look at this graph, if I look at the green graph, the 4 tells us that the starting value is 4, and we can see that on our graph right here, the y-intercept. And it's increasing because the 2 is associated with the exponent x, which means that your numbers are doubling every time. Now, if something is decreasing, right, the A value has nothing to do with it, which in this case for our blue equation here, y is equal to 2 bracket 1/3 to the x. The 2 is the starting value, but this one says every time we move to the right, we only use a third of what's left over. So basically, we end up chopping it down to a third each time. So that is decreasing. So in essence, if you think about it, what these graphs are telling us is that if we have b greater than 1, so for our green graph, if b is greater than 1, the graph is increasing. So if I look at this equation, y is equal to 4, 2 to the x, the b value is 2. The 2 is raised to the x, just like the b was raised to the x. So that means because the number 2 is greater than 1, this graph is going to increase or explode exponentially. Now, if I look at the second graph, the blue graph, which is y is equal to 2 bracket 1/3 raised to the x, you'll notice that the number is a decimal, i.e. a number between 0 and 1. So that's where we have, if b is greater than 0 but less than 1, then the graph is simply going to decrease. So it's going to swoop down. Okay? Now, I'm going to give you some questions. Take a moment and copy this down, and we'll move on to the next problem. Okay, so now we're going to try and sketch these graphs based on these ideas that we took a look at before. So suppose I have y is equal to 3 bracket 1/5 to the x. So our initial graph looks like this. We start with our basic Cartesian plane. And when we want to graph this, we have to understand what our starting value is. In this case, our starting value is going to be 3 because it's y is equal to 3 bracket 1/5 to the x. Now, the 1.5 raised to the x basically tells us that this thing is increasing because anything raised to the exponent x is representative of the b value, which tells us whether this thing increases or decreases, like we said before. So the b value here is greater than 1, and in this case it's 1.5. So this graph is going to look like this, with our 3 crossing the y-axis for our starting value, and it increases because our b value is above 1. Now let's take a look at this equation here. Y is equal to 5 times 0.5 to the x. If you look at this equation, the starting value has to be 5. But you'll notice the value that's raised to the x is between 0 and 1, like we said before. So that means the graph is going to decrease. So we're going to end up with something that looks like this, with 5 being our y-intercept, and instead of growing slowly and increasing, it's going to start big and decrease quickly. And that's all we're doing for our graphs today. What you need to be able to do is you need to be able to sketch these things. So what I want you to do is I want you to take a look at these questions on page 391, and you're going to do questions number 3 and 4. Good luck.